the Automata and Final languages. So we will just start with some little bit this history of this automata, and let us say is my screen visible?
Yes, sir.
Okay, automata. So our topic is all about automata and finite languages, right? So you also call it the what you can call the AFL, right? So I am an instructor in this class. So I'll just go through some of the little bit what you can say the introduction, and then we will start go for the what you can call the notes to look into this topic. So one thing that we have to go, so this is automata and final languages. One thing we have to understand first that why was the machine is so the we'll go first through these languages, okay? So we will talk about these languages, and then what you can call this is a then we'll talk about what is the automata. Okay. So why this automata and finite languages, these both words, these keywords are important to this topic, right? So when you're talking about the thing is that we interact when we talk. So we talk through different kind of languages, right? So some vernacular languages that are there. So we learn in talk to each other in Hindi. We talk to each other in Bengali. We talk to each other Telugu. We talk to each other Tamil. So there are different vernacular medium languages that we really use to talk with our languages, and different kind of languages. So why is the language is important? It's a mean of communication. It's a mean to do all our daily work, and this help our daily needs, right? So if I do not know a language, and if I go into some setting where my language is not known, I'll be a failure in there. I'll die of hunger, might, right? So in the same case, again, when we are talking about a language, and if you have let us say a novice user who has never seen a computer in his life, if he is given a computer again, then again he will not be able to do anything, right? But again, a programmer, when he is given a computer, he knows the language to how to talk with that machine, and then he will write some beautiful programs, right? Beautiful programs to solve some daily to solve our daily problems, right? So marketing, everything can be done on this one. So why is finite languages? Why these two things are coming together? Why this automata and finite languages are coming together? So automata and finite languages are coming together because since we humans interact with each other through languages, there are machines we need to talk to. So machines also understand a particular language, and through which they can give us some output. So right, so that is how the machines work. So the language is a very important part of our discussion. So again, the language again we discuss in this in here is again we have described it mathematically, right? So that again this language is understandable by the machine, right? So first we have to understand what is a finite language, and again how does it we talk to all about. So finite language is what you can talk to about is, let us say, we have to talk about symbols. Again, we have to talk about the alphabets, right? Then we have to talk about the strings, right? Then we have to talk about the what you can call the operations that are applicable on strings. So right. So all these things, when if we go in a top-down approach, if you go from the symbols, alphabet, strings, and operations on string, these are the ways you can constitute any language, right? And whenever you're talking about a automata, say, let us say, if I just remove this word and I just put some block, right? Say, let us say I am putting this one, let us say not this one. Okay. So let us say this is one, some input string is there. Okay. And let us put some like this. Say, let us say the string is something 0, 1, 0, 1, 0, and again 0, right? And this all goes on like that, dot, dot, dot. Okay, so now this is a input string, right? And let us say there is a machine in there. So let us say there is a machine now in here. Okay. So we can call this as a control unit. Okay. And let us say, okay, this is the control unit. And let us say it has a reading arm, right? It has a reading arm. So let us say it is reading in this one. One second. Okay, so it is something reading in this one. Let us say it is reading some. Okay. So this is reading the third, let us say, symbol. So let us make it a little bit waitful. Okay, it is reading this one. And let us say for computing purpose, it has to keep some of these symbols that it is reading. It has to store this for computing purpose. It has to store some of these things, right? Store some of the data that it is reading into another small file, right? Small, let us say memory type. Okay. So it has to continuously interact with this memory, right? Okay. So let us say, because it wants to store some symbols to do some operations, right? And it is continuously talking with this small storage device, right? So let us say, and then again, after reading and after interacting with this memory system, it has to produce some output, right? So let us say it has to produce some output, right? So again, it has to produce some output. So I think this symbol should be something like this. That would be better idea. Okay. So let us let us make this sign something more different color. Okay. It is interacting with this memory and then it is outputting something. Okay. So this is what you can call. So this whatever input tape is there, it represents a particular string of a particular language, whatever language we want to talk about, right? Nowadays, you see the ChatGPT engine that is there. It can directly understand the what you can call human languages, but earlier it was not there. So it has to understand from the machine languages. So I have written 0110. Now it is got into the control unit. Control unit is processing it, and sometimes it is storing it, sometimes it is calculating and then putting the data into back into this one, and it is outputting in this to this one, right? So that is how a normal automata should look at it. But again, when you're talking about this one, we have to let us say put these things in here. This is a let us say input tab, and let us say this is our memory. So this is how in general our automata should look like. But again, we have to understand that we have to first understand that what are actually these things are actually, right? So the first thing is that we have to understand first that what is a language again, right? So that it can be understood by a particular machine, right? A particular so languages are again also specific to a particular kind of machine only. A machine can understand a particular kind of languages only. Then we can understand a different categories of languages are there, and for each kind of languages there is a particular different kind of machine, right? So this is one we can call as a, let us say, this is a in general form of a the machine that we can call as the Turing machine, right? But there are multiple simple languages are also there for which a scaled down model of this automata can also work, that it can work without memory also. So in that kind of machines, we do not read this memory. It can just read, it can just, the major function of that machine is that either it will accept or reject any input, right? So that kind of machine is what you can call the finite automata. So we will start with that basic kind of machine that we can call as the finite automata. And then slowly, we will go and understand what are the other languages that are there, regular, then it comes context-free languages, and then it comes what we can call context-sensitive languages, and then again we can say that unrestricted grammar, and for that we can develop this kind of machine that is what overall the this one Turing machine. Okay, so any question till now? Any question till now?
No, sir.
Okay. So again, when you're talking about the symbols, right? So when you're talking about symbols, right? So what is what you can call about a symbol? It is a building block, right? Of any major language system, symbols forms the basic buildings blocks. So for examples, for binary language systems, the major thing is can be what you can call as the symbols can be 0, 1, right? For this one, alphanumerics, it can be A, alphabets A, B. This is English alphabet. So these are the symbols that can make makes any kind of languages, right? So when you're talking about, let us say, when you're talking about this, so when you're talking about these symbols, they form the basic building block of any languages, right? Now, when we take a set of symbols, now let us say there can be any kind of symbols. Now, if we take a set of symbols, so it is also called an alphabet, right? So strings is what you can call a set of symbols is called an alphabet. So let us say it's a 0 and 1 for binary numbers, right? And then again, let us say for English alphabet A, B, C, dot, 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 to let us say Z, right? So again, for decimal number system, it can be, let us say, 0, 1, 2, dot, 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 till 9. So these are what you can call the different alphabets. So alphabets can be also, let us say, in, so when you're talking about alphabets, so how can you define an alphabet? So alphabet is, let us put an equation in here. So alphabet is generally used as a, let us say, the sigma, right? So one thing. So alphabets are generally represented as sigma, right? So I'll just take this one and just put it in here. Okay. Okay. Now then comes what is kind of the strings. Now what are strings? What are strings? It is a sequence of symbols from a particular alphabet. Right, it's a sequence of symbols from a particular alphabet, right? So how we can form a strings from? So let us say uh, now let us say binary string, right? So binary string can be how it over an alphabet, over the alphabet, right? So it can be like this one. Let us say 001, 10, like that, 111, 0. Like these are binary strings, right? Alphabetic strings are how they look like. So let us say alphabet. We cannot say that English alphabet. Let us take as English alphabet. So let us say running, walking, okay, and let us say KKLSY and DDKLA, right? So is this okay? So my question is to the student group is okay. Is this an alphabet? Running, walking is an alphabet, and this KKLSYD is also alphabet. Do you agree or not? Do you agree? Both are alphabets, or these are not alphabets, or these are alphabets? Any answer?
Alphabets.
All are alphabets. So everything is a particular string, right? So all are strings actually, right? These are all these are all strings of a sequence of symbols from a particular alphabet, right? And then again, when we're talking about this one, operations of strings, so you know there are multiple operations of strings are there. So what are the operations that are there? Tell me. What are the different operations
So,
on strings?
union, concatenation.
So let us say union, right? Intersection, concatenation. Risha, any other thing? Any other thing you know?
Closures.
Reverse, right? Substring, right? Prefix, suffix. So these are all the different, actually, the different operations that are applicable on strings. So we all apply these things in this one to create a particular language, right? And again, there are certain different kind of languages are there. So let us understand. Let us go so far to some examples. Okay, when you're talking about this one, that is the Indian. Okay. Uh, so these are actually union, intersection, concatenation. So these are what you can call, if you're talking about intersection, let us say talk about union. Is it audible now? Is it audible now?
Yes, sir.
Okay. You have to tell me, right? You have to unmute and tell me that my voice is not audible. Okay, now sort of the substrings of this one. Acha, can there be a string called null where there is a string of no symbol, right? It can be there, right? So let us say a string with no length, zero length. So what is the symbol one? Let us put this one. So there can be multiple symbol of it. So generally we put this one lambda. Lambda can it be visible? This one, right? And then what are the substrings it can be? 0, 1, 1, 0. Then what are the substrings other than that can be 0, 1, 1, 1, 1, 0, right? And but we can see is the although we can form a substring, we cannot form a what you can call a contiguous one, right? So again, let us say if I take a now triple symbols, so it will be 0, 1, 1, and then 1, 1, 0, and finally the string itself, that is 0, 1, 1, 0. And then again comes the prefix and suffix parts. Okay, is this understood? Okay. So now there are different kinds of languages that are there, and we can say what you understand this one, that what is an automata does look like. So again, when you're talking about this kind of syllabus and topics, so again we have to understand that again we have to define what are the languages, right? We have to go start from the very basic language, and then we have to go for the that is what you can call complicated languages. And then we have shown the whole Turing machine concept in here. But again, when you're talking about a machine that can understand some very simple finite languages, then we go for jump towards a little bit complicated languages. Okay. So today's we will just today again let us we will just cover. So this is your notes. I'll just send it to you. So when you're talking about automata and finite language, we have to understand the preliminaries. That is a set. What is a collection of unique objects or elements? And then again we can call so operations, union, intersection, set difference, Cartesian products, all these things you know. What is a symbol? Well, I already told you. This is a basic building block which can be any token, right? A, B, C, 0 to 9, any symbols. It can be alphabet, finite and non-empty set of symbols. It is denoted by the upper sigma, right? And then there is the English alphabet, binary alphabet, decimal alphabet, hexadecimal alphabet. These things are all there. What is a string? It's a finite sequence of symbols over an alphabet, that is 0, 1. So length 0 string or empty string is called lambda or epsilon, whatever you want to call. Length 1 is that length should be 1. Length 2 is its length should be double 0, 0, 0, 1, 1, 0, 1, 1. Length 3 is 0, 0, 1, 1. So these are the generally a string is represented by W in our topics. Now, what is the power set of a set? Set of all subsets in a set. You already know that. What is the power set of a set? 2A. So no symbol A, B, and AB, right? And when you go to this one, so what is the power of an alphabet, right? So power of an alphabet is what? So we do this one, the upper sigma, and we put an I here where I is equal to 0, 1, 2, 3. So if I say that this sigma is equal to 0, 1, that means it is an alphabet of size 1, right? 0 and 1. So alphabet consists only two symbols, 0 and 1. When you're putting 1, it becomes again the same. Now, when you're doing alphabet square, right, or the what you can call sigma square, it means that all two length strings over a particular alphabet, that is 0 and 1, right? So when I'm doing alpha square, this one is becomes what? 00011011. So it cannot be more than, since it is a binary string. Now sigma cube means all the three length strings, all strings of length 3 over the alphabet 0 and 1. So again, when you're putting the 0, that means it is an empty string. It doesn't have any length. Now, what is the variation of the power of an alphabet? So one is the sigma star or star closure, or it's also a clean closure, right? Now it is what? It is a union of all strings of all lengths, right? So it should be always greater than equal to 0. So if I write sigma 0 union sigma 1 sigma 2, so it includes all the strings including the empty string, that is lambda or epsilon. But if you remove the, what you can call, if you remove the empty alphabet or empty string, that is a lambda, from this particular string, it becomes what? It becomes a positive closure. So that is the major difference between the star closure and the positive closure. So star closure means what? Star plus, sorry, sigma plus union sigma to the power 0, or sigma plus union the alpha. Now, what are the functions of different strings? Length, we have to understand what is the length. Concatenation, we concatenate two strings W1 into W2, we get the strings in here. Replication, process of repeating a string pattern by a specified number, right, denoted by Wi. So if I write W is equal to A, W to the power 1 is equal to A, W square is equal to A square is equal to A, W cube is equal to A cube, that is all the length of A. So this is what you can replicate, the lengths of different string are represented by the W. And reversal means we reverse a particular string. So WR means we just reverse it. So 1 2 3 becomes 3 2 1. Now what are the different relation on a string? One we already discussed in here. Substring. A string X is a substring of W if X is a contiguous part of W. Contiguous, this word is very important. Contiguous means it should be a continuous part of that string. If it is if a string, there is a string in there, and if you want to take a substring out of it, so the thing is that it should not be not connected. It should be all connected. So if I say W is equal to XY, the substrings are XY, and lambda. W is equal to XYZ, lambda XYZ, XYYZ, XYZ. So what is the path that is missing? XZ is missing. See, XZ is not connected, right? It has to be always connected with Y. Same thing with this one, W is equal to XYZ P. So what are the number of substrings of a string, right? So it is n into n plus 1 by 2 plus 1 because of lambda, right? So we have to always, so how many, the number of substrings of a string is n into n plus 1 by 2 plus 1 because of the empty string that we have. Now what is the prefix of a string? It is the beginning or contiguous part of the string W. W is equal to XYZ, and what are the prefix? See, there is no symbol in here, right? There is no symbol in here, so it is what you can call the empty symbol we have to put, lambda, right? Then we see come from here left to right. If you go, then it is X, then XY and XYZ, right? See, Z cannot be part, right? Z becomes the suffix part. Now if you come in the suffix part, we have to start from the right to left. Suffix part right to left means what? The rightmost symbol is nothing. So I can put lambda. Then again we can put what? Lambda, Z lambda. So I put in here Z. Lambda cannot be, so lambda is not by any, it can be what you can say like a space, right? Then again, what is the symbol that comes? YZ, and then again what it comes? XYZ. Now, what is a language? It's the denoted by L, right? It is a set of all strings over the alphabet that is represented by sigma. So the language belongs to the sigma, right? It's a set of all strings over a alphabet sigma, right? Now there are informal languages. The language that we speak are talking about, these are called informal languages. Fan, right? It has a meaning. It concerns with the rules and meaning. So these are all informal languages. And then there are what you can call the formal languages, AFN, right? It can be any kind of sequence of symbols. Language that contains strings such as string starts with A and ends with N, right? So it can be AFN or FAN. But in here you see that fan is invalid string, because what you have defined the language, It contains all the string that begins with A and ends with N. So it concerns with rules and significance, but not with the meaning. It is also called syntactic languages. Now, what are the focus on formal languages? So we just in our topic, in our syllabus, we talk about only formal languages. What is the formal languages? It's a tell me. It's a set of all strings over an alphabet, and it has concerns with rule and syntax, but not with the meaning. Right? We are only concerned with the rules and syntax of forming different strings within a particular language over a given alphabet. Now, when you're talking about focus on formal languages, they can be defined like English like a format, right? Language that contains a string that it starts with a, right? A B over an alphabet, over that alphabet A B, right? A B. So A, and after that you can put anything. It becomes a part of that. All the strings become part of that language, right? And again, when you are calling a set builder format, we can write like this also: A W, right? W belongs to A B star. So W belongs to what you can call clean closure of the particular alphabet A B star. So in that way also we can put the language in a set builder format. So in here you can do any kind of exercise, a language which ends with B over the alphabet AB. So you have to also always mention what is the alphabet, because we have to form different strings from the given alphabet set, and as per the rules that define the language, we have to build the set. We have to build the set contents, right? So again, when you're now we come across we have understood what are languages. Uh, have we understood what are languages? Yes or no?
Yes.
Yes,
Okay.
sir.
Yes, we have understood what is a particular language. Acha, how the languages start from? What is the basic building block of any language?
Symbols.
Okay. So what is an alphabet?
A group of symbols.
A finite non-empty set of symbols. What is a string?
A collection of some symbols.
Hmm, any other definition? Anyone else?
Collection of symbols from a set of
No, no,
alphabet.
collection of symbols is okay, fine. But what is the thing that is
Sequence of
missing? It's a sequence, right? It's a sequence of symbols. Collection of symbols is a collection of strings or symbols, what you can call, it can be called as an alphabet, right? So when you're talking about a sequence of symbols, then it becomes what you can call as a string, right? Then what is a language?
Sir, collection of strings which are grammatically correct is considered a language.
Grammar, we'll talk about grammar later. Okay. So again, when you're talking about a language, then again, it is a collection of strings, right? It's a collection of strings defined over a particular alphabet, right? Defined over a particular alphabet, which follow certain rules, right, of the particular language. That we can call as a language. So we have to be very, very particular about this one. So symbols are basic blocks, alphabets are group of symbols, okay, set of symbols we can say. Strings are sequence of symbols, and what is a language? It's a collection of strings defined over a given alphabet. Okay, so this thing has to be very, very clearly understood. Now, when you have understood what is a language, right, then we have to also understand the machines which can understand it, right? So if I'm talking in an informal language, I'm talking in an English language with you, your brain is continuously evaluating, your brain is continuously talking to it, understanding the language, it is forming its own meaning, and it is trying to understand, trying to store some of it, and trying to talk to me about it, right? The same thing is happens with what you can call the machines. So in here, languages that contain strings are, okay, so these are languages. So this is what you can call as an automata, right? This is the input, this is the controller, this is the output, this is the storage, right? and slowly now we have to define it. Now, right now the control unit, right, when it reads a particular symbols, it in the beginning it is in a some initial state, right? Now what is the state? It is a like a what you can call, that this is a certain kind of condition that is dependent upon a previous set of state and also the previous state of inputs. So the control unit can be in any kind of finite number of states, right? A state is a situation of systems depending on the previous inputs and causes reactions on the following inputs, right? So, so let us say, if you know in your watch, right? If you take your watch out, if you take your Casio watch, if you take your digital watch, right? You see the numbers always increases. It never decreases, right? The second increases, the minutes increases, the hour increases, right? It never goes back. But when it happens, when the time period crosses, it goes. Let us say second goes from 0 to 1. It cannot go back. 1 to 0. It cannot go back, right? And again, when a time series happens, when a time sequence happens, it goes to 1 to 2, but it cannot go to 2 to 1. So when I am saying that what is the time in your watch, I am asking what is the state of your watch, right? So you still the state of the watch is what it is now, 3 o'clock and 43 minutes, right? And you generally do not talk about the seconds, right? So it's a situation of system depending on the previous inputs and causes and reaction to the following inputs. Now, what is the configuration? Now, state of control unit, input and storage. Now, in a always if you see a system, they are in a certain point. So, they can be in a certain state of control unit, their input or storage, and they move from one state to another depending upon the current state and also the given input. Now, what is the transition functions? Your watch clock moves after a certain period only, right? So again, for this one, for our automatas, we have to define some state transition functions, right? Now again, based on the output. So see, we take the input from the input tape, it interacts with the storage control unit and gives out the output back, right? Now what is the output? It can be, so if it gives a output, particular like in form of, again, it also outputs a string, then we can call it's a, let us say, millimori machine. But if it doesn't give an output, it only gives an answer in the form of yes or no, we call it an acceptor machine. So in this topic, we will generally discuss about the acceptor machines, whether the input string is accepted or rejected. Now again, when the control, now then there is a what you can call machine based on control. Deterministic means, so let us say deterministic means it goes from unique one state to another next state, right? Unique next state from the current configuration. So let us say when you're talking about deterministic machines, what happens in these cases? So let us say the second moves to the 1 to 2 it goes, 2 to 3 it goes, right? But it goes to, if it what is in 1, it can go to 2 only. It cannot go to 3. If it is in 1, it can go to, if it is in 2, it can go to 3. It cannot go back to 1 or 2. So it goes to a next state from the current configuration. But when you're talking about non-deterministic machines, so there are several possible next states are there, right? Several possible next states are there. So let's say non-deterministic machine, if I take this one, let us say a random number generator, right? So if you're talking about a random number generation, so a number can be, so let us say I want to generate any random number from a particular digit, from this one, let us say from decimal numbers. So if I'm stating the current number is 5, the next state can be 9 also, and the next state can be 1 also, right? So that is what you can call something called as a non-deterministic. So non-deterministics are generally more powerful machine than the deterministic ones. So the syllabus is this one. So first we'll talk about the what you can call finite automata, right? So finite automatas generally work on regular languages, right? And the regular languages are generally defined by the regular grammar, right? Finite automata machines do not have memory, right? This is a finite automata machine. So it is a scaled down version of this machine, right? So this memory in here, this is not there in a finite automata. So this generally work on the regular languages. So what are regular languages we'll discuss later. Correct. What are regular languages? How are they defined by regular grammar? This will define later. But first, we will discuss about the finite automata. But finite automata is again not fit to talk about the what you can call they recognize not able to recognize the context-free languages. Now, context-free languages, then there is a separate automata that is there, that is a push-down automata, right? And then there are certain recursively enumerated languages that are there. So then they are not recognized by the push-down automata. For that, you require the Turing machine. So in this way, we will go through. So first, we will study about finite automata. So today you are all free, so we can take the class. Hello.
Yes, sir.
आज क्लास ले सकते हैं फिर से?
ले सकते हैं सर.
ना एकदम सुबह से ले. सुबह 7 से 8 आप लोग फ्री हो क्या? हेलो.
हाँ सर, फ्री है, कोई दिक्कत नहीं.
ठीक है, 7 से 8 हम लोग कोशिश करेंगे. ठीक है, ओके. टुडे आज क्लास यहीं पे रख देते हैं.
ओके सर.
ओके, थैंक यू.
नेक्स्ट क्लास होगा.
हाँ बोलो.
नेक्स्ट क्लास कब हो रहा है?
नेक्स्ट क्लास में आज रात को बता दूंगा.
ओके सर. सर प्रेफरेबली हो सके तो मॉर्निंग में रख सकते हैं क्या?